Kardashev scale and the epic scale of spacetime. Even in a universe as big as ours appears to be, there is a chance we are the only advanced intelligent species alive at this time. The Earth is some kind of rare in the Milky Way galaxy. No matter how scientists slice it, our planet is special. And this isn't the anthropocentrist in me making a statement. The Earth settled into just the right orbit and had just the right combination of elements, and just happened to avoid collisions large enough to completely shatter it. We are sure one of the luckiest planets in the galaxy, if not the universe as a whole. And for billions of years, life has been exploding and blooming all over our beautiful, wet, warm world, taking countless forms in every effort to find just the right ones that might be able to thrive for millions, even billions, of years. We've been sending radio signals and other emissions into space for over a century, and actively looking for signals from other nearby places for decades, and there still hasn't been a visit from a spacefaring civilization or a message we could say came from another advanced intellect. There are a few serious problems that are hampering this. Distance: our Milky Way is roughly 100,000 light-years across. The universe, as we have observed so far, is at a minimum roughly 91 billion light-years in diameter. It is bigger, but it's so big we just can't see yet. To cross our galaxy end to end would take 100k years moving at light speed. Ridiculous. That's just to cross it in a straight line. Covering the actual volume of space enclosed by the Milky Way in our fictional USS Enterprise would require hundreds of millions of years. If the galaxy, and the universe, are so damn big, where is everyone? This question has come in many forms, but most recently we've narrowed it down with more data as our technology has progressed. Even if the Drake equation is remotely close to representing reality, which it probably is not, based on some of the more optimistic values ascribed to some of its variables, the sheer scope of space would still create barriers for us in finding evidence of others out there and for the others to find us. It's the needle in a haystack problem applied to a haystack of nearly infinite proportions. Human time, the first problem. Size is one thing. The size of space can be written out and compared to things we see in the here and now. We can almost understand it. But time is another beast altogether, because we all have a fixed limit on it, in many increments, that begin when we're born and come to a point when we die that might be a complete hard drive failure or just a Control-Alt-Delete moment. A lucky person gets 90 or so years to experience the entire universe from a few minuscule areas on a tiny pale blue dot in a small solar system floating in a single arm of a relatively little galaxy in the midst of a single 54-member galactic cluster that is part of the Laniakea supercluster, which is only one of 10 million superclusters in the observable universe. 10 million, observable. So the size of space is insane, but we're talking about time now. And, it turns out, even though the size is a serious obstacle, we can handle size as long as we have the time to do so. Time is our limiting factor. If we can surpass light speed, maybe via the Alcubierre warp drive or utilizing wormholes or some other as yet unthought of possibility, then we only need the time to explore the universe. Of course, to get to the point that our technology needs to be in order to even be able to consider covering galactic and intergalactic distances, humanity will likely need to survive centuries longer than we already have. This means overcoming our inherent tendency to do things that threaten our own existence as well as all other life on Earth, and also avoiding natural and cosmic catastrophes that could cause our extinction, or send us back to a pre-industrial level. But the amount of time we, personally, have as a species is only one side to the role time plays in our situation. Cosmic time, the second problem above. I've written about time as it affects us, humanity, in our own struggles. We must last long enough to have a chance to further explore the universe. But the scale of time since the Big Bang, the birth of our current universe, is a different issue altogether. The late Dr. Stephen Hawking has calculated that time began some 15 billion years ago, when a singularity of infinite density began expanding, creating time and space, and we know it. It took life on Earth, roughly 4 billion years to develop anatomically modern humans, and it took humans 200,000 years to reach the stage we're currently enjoying, sending all sorts of signals radiating out into the cosmos along with tons and tons of beautiful space debris like Pioneer and Voyager. And that most recent stage, during which we've been able to be heard across interstellar space and been able to possibly hear signs of other advanced civilizations, has only covered the past 100-odd years since Marconi sent the first radio signal in 1895. Even though life has been around for quite a long time on Earth, no one else would have been able to find out about it until what is essentially right now, a very short segment in a very, very long timeline. We could be the only intelligent, sentient, technological species living in the Milky Way right now. In fact, the odds of just that are probably well over 90% because of the tremendous spans of time involved. Are we a single, lonely mind among a galaxy full of single-celled life? If we are, can we survive billions of more years in the hope that one day our civilization's lifespan might overlap with another that is intelligent? The Kardashev scale in 1964, Russian astrophysicist Nikolai Kardashev, who had been searching for evidence of potential intelligence in cosmic signals, devised a scale by which we might measure the levels of technological advancement such civilizations might display. This came to be known as, rightly, the Kardashev scale, and it breaks technological civilizations down into three main groups, based on how much energy the society has access to use: type 1 to the power of 6W, type 2 squared to the power of 6W, and type 3 cubed to the power of 6W. Since 1964, some astronomers have added type 4 to the power of 4 to the power of 6W, and type 5 basically infinite energy access. It is important to understand where the scale officially begins. With type 1, the amount of energy available to this civilization equates to all of the radiant energy that can be harnessed from its nearest star. In our current state on Earth, where we utilize fossil fuels and have barely scratched the surface when it comes to the possibilities of solar, geothermal, nuclear and other sources, we are still what might be called a type 0 civilization. It could take a couple of centuries for us to get close to being a type 1. A type 2 civilization can harness all of the energy available from a star, not just radiant energy. A civilization at this level might encompass a sun with a Dyson sphere to collect every bit of heat and light it outputs, and might also have a mastery of fusion and be able to create a power source that is nearly star level on its own. Type 3, being able to control energies of stars, would be so advanced that they would likely be in the process of galactic colonization, and given enough time, millions of years, perhaps longer, eventually be able to harness the energy of their entire galaxy. Types IV and V were considered too fanciful by Kardashev himself, taking the harnessing of energy to the universal and then all potential universes levels. If going from type 0 to type 1 takes a civilization roughly 500 years, starting with the beginnings of our industrial use of fossil fuels, then the growth from type 1 to type 2 might take another 1,000 years, and from type 2 to type 3, another several thousand years would be expected before any appreciable amount of galactic colonization might be occurring. Time versus the Kardashev scale. Humanity needs to avoid or prevent its extinction for thousands of years to go from an earthbound technological level to a truly spacefaring level. Only then will we be close to extinction-proof, minus the inevitable heat death of the universe. So, we could say that just about any alien civilization of comparable intelligence might have a window of opportunity similar to ours, 5,000 years, in which to kickstart technological advancement and build it up all the way to colonizing worlds around stars other than their own. 5,000 is 1/3 millionth of the time that the universe had been around so far, 15 billion years. Charles Chu writes about the many technological leaps that humanity could have made long before we actually did in this article. It's a very interesting topic and offers some insight into this next thought: our own 5,000-year techno-trek is based on our current pace. For some other civilization, it might only be a 2,000-year investment. For another, it could take 10,000 years. In all the billions of years that have come before our little 5,000-year window, how many alien species had their own opportunities? And if they did, how long ago did they actually occur? Because of the sheer length of the universal timeline, even if there have been thousands of other intelligent species that reach the window, the odds that any of them are currently, right now, overlapping with us are slim. We won't find type 0 or type 1, or even type 2 civilizations. What we would find is type 3 or higher. Why? Because a civilization must first survive through their window of opportunity, all the way to the point where they open it and fly out to colonize the endless stars beyond. Only then would they be at a level of technology that could allow for interstellar travel at speeds that make exploring our massive haystack of a galaxy for other needles like, or nearly like, themselves. In Dr. Hawking's 2016 documentary, Favorite Places, the preeminent astrophysicist again stated a thought of his that meeting an advanced civilization could be like Native Americans encountering Columbus. That didn't turn out so well. It's most likely that whenever we do encounter intelligent aliens, they will be at least a level higher than us on the Kardashev scale. And, given that once we make it through our own window of opportunity we might be assured humanity can exist for many thousands, if not millions of years longer, it may be inevitable that we do meet another intelligence despite the vastness of time and space. Earth is likely not the only world that harbors life. We are probably not the only intelligent, technological species. But we could be one of the earliest or one of the last. So we'd better get cracking. There's a lot to do for us to be ready when the time comes. Thanks for watching.